All right, welcome back. So today we're going to go over the modulus operator and the floor division operator. And the modulus operator gives you the remainder of a division, and the floor division gives you the whole number. So for example, let's say we have 10 divided by 3. It would look like that. And if we had the same thing with the modulus operator, we'd be given the remainder. So simply, 10 divided by 3 is just going to be 3.333 continuous. And if we do 10 with the floor division, we're just going to get the 3, the whole number. Now, with the modulus, we get the remainder, which is 1. So 3 times 3 is 9. So it's not really 10, but when you divide 10 by 3, you're going to get 3 and a remainder of 1. So that's as simple as it can get for the modulus and the floor division. So let's say we have maybe an input of x is equal to any integer. Now we could do a system of evens and odds. So if you input, let's say we input 3. It's going to do 3 divided by 2, and it's going to know that there's a remainder. So because the remainder is not equal to 0, it's going to go through f is odd, or the function where x is, let's say 3, that's going to be odd. Now if it were 2, let's say we just chose 2. 2 divided by 2 is 1 with a remainder of 0. So that's pretty much what this function is asking us. Now with the floor division, let's say we have a function of slices of pizza. So let's say there's 12 and we have 5 guests at the party. We can equally share 2 without having to divide a pizza and share it. So there's obviously going to be a remainder of 2 because 12 divided by 5 is 2 with a remainder of 2. So each guest can have 2 pizza slices. So yeah, that's applications and descriptions of modulus and floor division. So thank you for watching, and hopefully you learned something from this.